Okay, hi again everyone. Professor Sebastian in our statistics class notes on page 50, finishing up section 4.1 on regression analysis. Last thing in this section is I just want to make sure I point out to you that you need to be careful when describing associations. We always want to use a phrase like tends to. You've seen me use that over and over and over again so far in the examples when describing an association, because the trend you are describing has variability. It's not usually a perfect line that fits through them, right? You got dots scattered about. So the association you're describing may not be true, and most likely is not true for all individuals. And when I say individuals, I mean all points in my scatter plot. Always point out any data points that appear to be unusual as well, or not part of the general pattern. Sometimes we should ignore them, and sometimes we should let the trend line be pulled towards it if it needs to be. Okay, we're on section 4.2, which is measuring the strength of the association with correlation. So far we just said weak or strong. Now we want to kind of have a measurement for that, a numerical measurement. That measurement is called correlation coefficient. A number that measures the strength of a linear relationship. Its symbol is little r, technically. Unfortunately, StatCrunch uses a capital R, but its symbol is little r. Always between -1 and +1. So in other words, it's a number that runs between -1 and +1. If the r values, or the correlation coefficients, are close to -1 or +1, that indicates a strong linear association. So this graphic here kind of gives you an idea of what I'm talking about. So if we have a perfectly positive, right, uphill correlation where a line would fit through that perfectly and there would be no variation away from that line vertically at all, that would have an R value, or a correlation coefficient, exactly equal to 1. Similarly, on the far other side here, if I had a line that would fit through a negative correlation like this perfectly, that would have an R value of -1. When you get down to R values that are close to 0 or approximately 0, there's just no way to tell where a line should go through that. Okay, if it's strong and positive, the values would be kind of tightly clustered around the line, and as it gets weaker, closer and closer and closer to 0. Again, weak negative, close to 0, stronger negative, closer to R equals -1, etc. So take a look at that and make sure you understand how that works. It doesn't mean that's the slope of the line that goes through it. It just means that that's tells you the strength of the correlation between the lines. Okay. As an example, these again are R values of 1 and -1. They are perfect positive and negative associations. That's a perfect positive association with an R of 1. This is a perfect negative association with an R of -1. These data points lie perfectly on a line. Okay, I'll stop there and come back.